let's go through the background. So previously you have understood some concepts like univariate data. Okay, like univariate so you have studied the dispersion central tendency. Okay, then dispersion, then skewness and kurtosis, right? So all these data were based on the univariate data. Okay, so univariate data means data based on the single variable. Okay, so when you deal with the correlation, then at least you want two variables. Okay, at least you want two variables. So such a data, when you collect information on two variables under study, bivariate data, we call it as a bivariate data. Okay, so this is very important. Now in this particular session, in this particular unit 1, we are going to deal with the correlation related to bivariate data. Bivariate data. So bivariate data means when you collect data on two variables under study. Okay, so such a data is called as the bivariate data, not any data. Okay, so we can give example: income and expenditure. Income and expenditure. Okay, then volume and pressure. Okay, then you can give example of uh, demand and supply. Okay, then price and demand. So in all these examples, we are collecting data on those variables which are interrelated, which are under our study. Okay, so though there must be some relationship existing between those. Such a data is called as a bivariate data. So what is the definition of bivariate data? So whenever you collect the data on two variables under study, okay, then such a data comprises of bivariate data. Okay, now you can understand why we have included this word under study, because see, income and supply may not be having any relation, or income or pressure may not be having some relation. Okay, height and weight have relation, but height and expenditure does not have any relation. Okay, so those relationship must be valid. Okay, so under study you consider those. Under study means those variables which you are interested in. Okay, or which the on which the research is going on, not any variable. Okay, so whenever we collect the data on two variables under study, such a data is called as the bivariate data. So remember, this is a very basic concept. Okay, so how the bivariate data is written like? So it is an ordered pair xi yi, where I takes values 1 to n, where n pairs of observations. Or it is also written like this. It is also written like this. Means there are various forms of data you can show. So there may be the x1. Means these are some values on certain variables. Suppose income and expenditure. Suppose this is x is income and y is expenditure. So this is the income and expenditure of first person, and this is our family, or this is the income and expenditure of nth person or n family. Okay, so this way you can represent. Okay, or you can also represent it in an ordered manner, means x1 y1 or x2 y2. So there are number of ways you can represent a bivariate data. Okay, so more precisely, if you want a real life example, then suppose uh, I have to collect the height and weight of the eldest son, height and weight of eldest son in 5 families, right? So this family number 1, 2, 3, 4, 5 is just for reference, and my variable is height. X means height, and Y is weight. So I came to know that now the values are in kgs. Okay, so now I came to know that height of this is in centimeters. It is 154, whereas the height weight is one. Weight is suppose 52. Suppose height is 162 and the weight is 54 and so on. So this data will make a Bible data. Okay. So family is a for just for referencing. We are concerned with this data. This is X1. So what is this? This is the height and weight of, this is the data on height and weight of first family, of first family, or first family having the eldest son, right? Okay. And similarly, this is the height and weight of second family. So, so I hope you understand. Now we'll move ahead. So whenever you understand, then you just let me know. Okay. So this is the concept. Now let's come to another concept. That is a correlation. What is a correlation now? So correlation is the is nothing but it is the study of relationship between the two variables, two or more variables. Okay, so it is the study of relationship. Okay, correlation means what? It is the study of relationship between two or more variables. Now specifically we are dealing with the two variables, so binary data. Okay, so it is the degree of relationship between the two or more variables. So it can also be said. Okay, it is the degree of relationship. It is nothing but the degree of relationship between the two or more variables. The same line I am repeating here. Okay, and what is the correlation analysis? So it is the entire procedure of studying the measuring the correlation between the two or more variables. Okay, so did you all understand this? What is correlation? It is the study of relationship between the two or more variables, or degree of relationship between the two or more variables. Is it clear? If you understand, then please blow your thumbs. Okay. Now types of correlation. Okay. Now during this lecture, I will not be going in detail, but basic concepts will try to clear so that you can understand further. Okay. So what are the types? What are the types of correlation? What are the various types of correlation? So basically we consider, now there are different kinds, there are different categories, but we are not going into detail. We are understanding very simple way. First one is positive correlation. Positive correlation. Okay. Then second type will be negative correlation. Negative correlation. Okay. And third one will be no correlation. If you can explain this, you are done. Or it is zero correlation. Okay. So let's try to understand this. Okay. So these are the three types of correlation: positive correlation, negative correlation, and no correlation or zero correlation. So what is the difference between them? See, I will explain it with the help of example. Okay. So first example, income and expenditure. Income, say it is X, and expense, I write in short, expenditure is Y. So you generally know that whenever your income increases, the expenditure also increases, or whenever the income decreases, the expenditure also decreases. Okay, so what you observe in this, you observe that either both increase or both decrease. So you can say that the direction of change in general, है ना? So you can say that direction of change is same. Both are either increasing, both are either decreasing. So whenever you observe the same change, same direction of change, you call it as a variables are positively correlated. Okay, income and expenditure are one example. Then you can give example of advertising cost and number sales. Okay, more you advertise, means advertising means you are pouring more money into it. Okay, so more money you will expend, then sales will be there, sales will be increasing. If you do not advertise your product, then you will not be getting a proper sale, right? So both the things are changing in the same direction. Okay, so positive correlation means we can define like when the direction of change is same, either both increase or both decrease, then such a variables are said to be positively correlated. Okay, I hope this is clear. Whenever you understand, please blow your thumbs by default, because it will give me that it will click me that you understand it. Thank you. So by default, whenever you understand your topic, any topic, then you click it or give thumb. Okay, then negative correlation. So now some examples you see, like price and demand. Price and demand. So this is one example where you observe that generally when you drop the price, you know, demand increases. Just like you can see in the market when there is a sale. Sale means what? 50% buy one get one free. It means that in the price of one item they are providing you two. Ultimately the price is reduced to half. Okay, so whenever the price is reduced, you see the demand increases, and vice versa, just opposite of it. When you increase the price, automatically the demand will decrease. So one thing you observe here, the direction of change, okay, is opposite. Means one is change, one is increasing, so other is decreasing, and vice versa. So such a if such is the relation between the two variables, then we say that the variables are negatively correlated. Got it? Then everybody understand this? So you can give more examples of it. This was the first example. The second example, volume and pressure. Okay, as the Boyle's law teaches you in the 12th, that volume of an ideal gas is inversely proportional to its pressure. Okay, so you can see that if volume increases, pressure decreases, and vice versa. Then no correlation or zero correlation. So when you say this, so when the variables under study are irrelevant, for example, I give you an example like income and temperature of the day, or day temperature. So what is the relation between this? Nothing. It's nonsense relationship, right? So there is no there is no relation. You can guess it that there is no relation there. So there is, so when the two variables are not related at all with each other, then such a variables are called as no correlator, zero correlation between them. Okay, so this was the part I have explained to you. So you have to, for exam purpose, you have to remember these three types. Further types also I will explain you. So other remaining types are, so other types are, now in the lessons which are coming further, we'll be learning the multiple correlation. We'll be learning multiple correlation. Okay, multiple correlation. Again, we'll be learning ahead partial correlation. So partial correlation. So this is all based on the number of variables. Okay, so when you have more variables, x1, x2, x3, and dash dash xn. Okay, so I'm not talking about the values, these are the variables. Okay, so when you have more variables, more than now in this example I will consider three only. Okay, so trivariate data. So now more than two variables means multiple. So when you are dealing with multiple correlation, then you see that there are three variables in trivariate data. This is called as a trivariate data. Trivariate data. And in that case, when we study the relationship between more than two variables, it is called as the multiple correlation. And partial correlation, when two variables are there, then more than two variables are there, but we are considering only uh, only the two variables. Suppose x1 and x2 is studied and x3 is kept constant. Okay, so this is the partial correlation between x1 x2 keeping x3 constant. Similarly, you can study the relationship between x1 and x3. Now you keep the x2 constant. So now this is the partial correlation between x1 and x3 keeping x2 constant and so on. The remaining pair will be what? Suppose you are considering x2 and x3 and you keep x1 constant, then this will be partial correlation. So partial correlation means when you study only two variables and you keep other variable constant, then such a variables are called such a variable partially correlated. Okay, so this is one type of kinds of correlation. Then linear correlation. Linear correlation and non-linear correlation. Non-linear correlation. What do you mean by that? A very important term because we will be using it. So multiple linear correlation means very simple. When you plot the xy data, xy axis, xy plane, if the points plotted fits the straight line, remember my point, when the points plotted fit the straight line, means you can draw a straight line from this point. Okay, so then such a data is called as a linear correlation. So you know, whatever, if x1 changes with 1 unit, then y also changes with the same unit. Okay, so linear relationship exists when there is a constant change. So दोनों वेरिएबल्स के अंदर में कांस्टेंट चेंज हो रहा है. So this is called as a linear relation. Okay, so I'm going to talk in detail in further units. So this time I will just give you hint about this. Now non-linear correlation. So non-linear correlation. Now sometimes you observe when you plot xy data on the xy axis. Okay, suppose you have data on income and expenditure. Okay, and suppose you do not get straight line. So other than straight line, suppose you get some point curve. You get a curve, right? You can get different shapes. Suppose you are getting like this exponential, right? So this kind of data. Or suppose you are getting, this is curve. Okay, so anything but not a straight line. When you plot the data along the xy axis, you are not getting straight line after plotting, then you call it as a non-linear. Non means not linear but other form. Okay, so I'll be explaining in detail in the units to come. Okay, so I just wanted to give you an idea. Hope you understand these different correlations. So if you understand the positive correlation, negative correlation, zero correlation, multiple correlation, partial correlation, linear and non-linear correlation, then please blow your thumb so we'll move ahead. Okay, thank you. So this was the question just now we have answered. Now you can write in your own words. Remember, uh, when you write in your own word, that is the best thing. Okay, not necessarily you should write word to word copy from any book or any notes. Okay, if you understand any concept, so you can write in your own words. Okay, but important thing is you should understand the concept properly. So looking at your response, I understood that. I'm sure that you understand the concept of correlation. Okay, so in this I will give you hint what to write. So you write the definition of correlation. Okay, first of all, and whenever you write in the exam, you be specific. Don't write anything irrelevant. If you think that writing anything or writing lot of things, writing number of pages, so it will get you marks. That's not true actually. Sometimes the questions are very tricky and simple answers are there. So you be particular. You should cover the points which is needed. That's it. Okay. So bulky writing, so not necessarily it is needing every time. Okay. So definition you can write. Then you should give examples of, okay, or when you are writing the types, you should mention the types. So these are the types of correlation: one, two, and three. And now rest of the thing, it is your choice, multiple and partial and all. So we'll be interested only these three: positive, negative, and zero correlation. And everyone you should give two examples. Okay. So it should be supplemented with the two examples. So two examples of each. So you have to prepare it accordingly. Okay. So if you understand the concept, so in your understanding, you can produce any example, but that should be valid. Okay. So this is the so definition, example, then types. And if you want to write further, then it is not asked here, but you can write the measures of correlation, various measures of studying the correlation. So it will, if it is not asked, but if you write this, there are 3 points only, short points. If you write this, it will make a really a good impact on the evaluator's mind. Okay. So or you will also satisfy. Okay. Then so we are coming to this measures of studying the correlation, various measures for studying the correlation. Okay. So if you write in that answer, that is fine. Once more time, uh, you understand that I'm focusing on specific writing. Okay. So writing too much will give you more marks. This is not true. Writing the correct steps, it is important. Okay. Measures of studying correlation. Okay. So what are various measures of studying correlation? So let us see. So there are three methods of studying correlation. First of all, Carl Pearson's coefficient of, one thing I forget, I'll call it as two. This is the second number. First one is the scatter diagram. First one is the scatter diagram. Second with the Carl Pearson coefficient of correlation. Okay, it is denoted by there are different way of notations. You can also denote it by correlation between xy, or you can also call it as a correlation between xy, or simply you can show r. Okay, so any one of the three notation can be used. Now then third measure is Spearman's rank correlation. So these are the three measures of studying correlation. Okay. So of which we are first of all come to the scatter diagram. Let's understand the scatter diagram and then we will see the other definition. So what is a scatter diagram? So I will try to give explain you in a very shortest possible way. Okay. So scatter diagram. What is a scatter diagram? Now in our daily life, we use the XY axis. Okay. So I will try to give one example. Suppose this is the data I'm having. Okay. So this is the random data I'm preparing here. Okay. I'm having some kind of data and now I want to plot it on XY axis. Okay. So scatter diagram means what? It is the in this is the simplest type of studying the measures of studying the relationship between the two variables. Okay. So what is a scatter diagram? It is the simplest way. It is very simple to understand. It is the simplest and easiest way of studying the correlation. How? Let's explain. Way of studying the correlation. Now, this is the example. Suppose this data is plotted. Okay, I'm taking in arbitrary data, and now everybody understand the cases. Okay, so forget about this data. I'm talking in general. Suppose all the points plotted. Suppose all the points plotted are in a straight line. Okay, and you know that this is the value of x, this is the value y-axis, this is x-axis, this is y, and you know that now this is the right side. If all the values are in the right side, right, are intended, our direction is towards the right side, you can see that the values are increasing. Okay, this value, suppose this is x1, this is y1, this is x2, this is y2, and those are in the straight line. If all these points, if we draw a line, then it will give a straight means all the points are such that they fit a straight line. So if such is the case, then we understand that there is a perfect positive correlation. There is a perfect positive correlation. If all the points plotted on the xy axis are in the straight line, then it is called as the perfect positive correlation, and in this case the value of this r is +1. Note that the correlation value lie between -1 to +1. Okay, in this range. So it is called as the perfect positive correlation. Just opposite to it, when all the points plotted are in the reverse direction. Okay, so they are in a straight line, they are fitting a straight line, but their direction is what? Reverse way. You can see that the highest lowest value, at lowest value of x, the value of y is highest. It is having the highest one, right? As the x increases, y is decreasing. So you can say that there is a perfect negative correlation. There is a perfect negative correlation. So what do you mean by perfect? Perfect in the sense it will take value exactly -1. If the points are fitting a straight line and their direction is like this, you say that it is a perfectly negative correlation. Okay, so understand the concept. You will never have to learn it by heart. Okay, so third one, if the points plotted, now sometimes what happens, it is not a straight line every time, then will not be a straight line, but if the points plotted are such that overall direction, when I say overall direction, then I'm studying in general direction. So overall direction is what? In the right side. Here it was a left side. So overall direction, you can see that the direction is what? This side. So you can see that there is not perfect, but just a positive correlation. So you can say here there is a positive correlation. You cannot say that there is a perfect, but why not perfect? Because it is all points are not in straight line. but though general direction is towards the positive side, so it is a positive correlation. There is a positive correlation. Okay, so in this case, the correlation value will be it will lie between 0, it will lie between 0 and less than 1. Okay, understand it? So positive correlation, it will lie between 0 and 1. Now, fourth one, are you all understanding? Please blow your thumbs. Now in the next case, just opposite to it, the points plotted. Thank you. The points plotted have general direction in the reverse side or opposite side. Okay. So you can say that, you can clearly see that the direction is like reverse. So when x is increasing, y is decreasing. Second point, these are not on a straight line. So you can say just a negative correlation is there. There is a negative correlation. Okay. So the values of R, correlation value, will lie between 0 and -1. Okay. So you can say that there is a negative correlation. Okay. Now sometimes the variables are not at all related. Okay. So means you cannot identify any direction in that case. Means these are very randomly scattered. Nobody can now see. You cannot see any specific direction, either left or right. So no direction is specified here. In such a case, you say that there is no correlation or zero correlation. And in this case, the value of R is 0. Okay. So in this way, using the scatter diagram. So what do you mean by scatter diagram? Scatter diagram means to represent the behavioral data using uh, along the xy axis and then identifying the correlation on the way it is plotted. Okay, so these are the cases under it: 1, 2, 3, 4, 5, and in this case you can comment upon the kind of correlation. First of all, you come to know what kind of correlation there, either there exists correlation or not, that you can identify. Secondly, if there is a correlation, then what kind of correlation it is: perfect positive, perfect negative, positive, negative. So this you can identify. Okay, so one more type exists there, which I will definitely mention. Suppose xy axis like that, there is a curve. Okay, so you call it as a non-linear correlation. As I explained it earlier, non-linear correlation. Okay, so you can also understand that by plotting your data on the xy axis, that whether there is a linear or non-linear correlation. Okay, so this is why it is the easiest way of studying the correlation. Okay, all of you understand? So now you have seen the merits of it, that it is the simplest method of understanding the correlation, or easiest method, but and it is very easy to understand also. Okay, I think nobody have any problem in understanding this, but there is a serious drawback. Okay, what is the drawback? The whenever you understand study the correlation using scatter diagram, it do not provide you the magnitude of, it do not give you the magnitude of correlation. This is just like that your results are declared and you are just knowing either you are pass or fail, but you are not knowing how much marks you got in particular subject or how much percentage you have got. You are not knowing about it. This is just like it. Okay, so you just came to know that you are either pass or fail, but you are not knowing your marks. So that is the same case over here. Okay, so scatter diagram will give you, or it will tell you about the uh, whether there is a correlation or no correlation, or what type of correlation is there. So that will be explained. But how much correlation is there? What is the numerical value? So it is not able to provide the numerical value. So this much is the strength, means zero point 0.8 is the correlation value, or minus zero point 0.1 is the correlation value, or plus 1 or minus 1. So it will not provide you that numerical value. So that is the biggest drawback, because when you compare, we need a numerical value. Are you agree with this? Now next we will move. Yes, thank you. Thank you very much. Now next, properties of correlation coefficient. There is one more topic given there, that is the regression coefficient. I will come to that part in the next unit. Okay. So what are the, okay, more types are remaining, right? Okay, I extend this page. I will explain the Karl Pearson coefficient of correlation, which is the best correlation method of studying the correlation. Okay, so I will simply tell you in detail, will not go, but correlation between xy. So what is the definition? So before studying the correlation, you need to study one important term, that is the covariance. And it is a very important term. If you do not understand the meaning of covariance, then you will never understand the meaning of correlation. Okay, whatever, in every topic or every aspect, there is some important terms. So this is the important term for correlation. Okay, so let's see, without means taking much time, we'll understand the covariance. So what is the covariance there? So I'll explain in a very simple way. Okay. See, I have a few data. This is the data one. Okay. I have two situations. Now there are two situations. Okay. So this is the situation one. I have a single data. I have marks of 5 students. What is the situation? I have marks of 5 students out of 50. Okay, so somebody getting 35, somebody 39, 42, somebody 28, and suppose 37. So these are the marks of 5 students. Okay, so when I'm studying the core, when I'm studying the variation within the same data, what word I will use? Within, among the same data I am studying the covariance, यानी कि 5 फ्रेंड्स में मार्क्स में कैसा वेरिएशन है. First one is getting 35, another 39, 42, 28. So when I'm studying the variation within the data, I call it as a variance. Remember, variation within the data. What do you mean by that? Means variation within the same data. What is variance? Variance is variation or difference. Variation within same data. Within same data. Variation within same data. Now this is one situation. Now we'll come to covariance. Now what is a covariance? Okay. So this is the situation. Now this already you have learned, right? So variation between these are sigma square. You must have find out this formula, xi minus x bar whole square upon n for ungrouped data. For grouped data, it is summation fi into xi minus x bar whole square upon total frequency capital N. So this you have already understood in the previous semester. Now in this, I will put another situation in front of you. Now you have two sets of data. Now marks of division D and marks of division E. From both the divisions, I selected 5 values, marks of 5 students. Okay, so suppose these are the marks from your division. 35, 39, and this is 42, 28, and 37. Now I take the marks of 5 students from D division. Okay, out of the 50, same condition is same. Suppose they are getting 29, then 34, then 45, then suppose 33 and 28. Okay, so what is covariance? Now here I am studying the difference between, understand the word, I am studying the difference between first student of D division with the first student of E division, and so on, second, third and third, and fourth and fourth, and fifth. So indirectly I am studying the variation between x1 and y1, x2 and y2, and so on. So when you study the variation between the two data sets, okay, understand my word, between two data sets, variation between two data sets, then it is called as the covariance. Co means what? Some another variable is there. Okay, so when you study the variation between two data sets, it is called as the covariance. Okay, so here the word I used is within, means the same data, and here between means two or more data sets are there. So this is called as the covariance. Now we are dealing with the covariance, okay, in this. So how it is called as, and what are the properties of covariance? So the way variance work for the univariate data, the same work is done by the covariance in bivariate data. Okay, so it is nothing but the variation between the data. Okay, and it possesses all the characteristic which the variance possesses. So what are the properties of it? So first of all, I will explain and give the definition, right? In correlation, many things depends upon this covariance. Okay, so let's start afresh. What is the formula for? And you have to note it down the various formats after solving it. Okay, so covariance between xy, the basic formula is summation xi minus x bar into yi minus y bar, summation I varying from 1 to n upon n. This is the very basic formula. Okay, after solving it, you will see summation xi into yi upon n minus x bar into y bar. So you can easily get this after solving. So we'll not go into detail how this arrived. Just follow the steps. You will ultimately land up to this final step. Okay. So this is the formula for the covariance. You have to remember it. Now where x bar means what? Summation xi, arithmetic mean of x. What is y? Summation y upon n. So both are the means of x and y series or x and y data. So now we'll come across the properties of covariance. Okay. So properties. What are the properties? So covariance between the same variable. Covariance between the same variable is nothing but the variance. Okay. We're not going to prove it because it will take too much time. Then effect of change of origin and scale. So change of origin means what? What is change of origin? So I explain you in this lecture. and in the next lectures I will directly refer. Okay, so understand. Suppose I take a set of values 1, 2, 3, 4, and 5. Okay, obviously the middlemost value is arithmetic mean. Okay, x1. So change of origin means what? Change of origin means if you add or subtract some constant to original data. Okay, so this is called as change of origin. So change of origin, suppose I take new variable, suppose y1. I'm adding here constant 2. Okay, so new values I will get here 3, here 4, here 5, here 6, 7. Okay, so this is change of origin. One more form there, if I subtract. So if I subtract 1 from each observation, so I will get a 0, 1, 2, and 3, and 4. Okay, so this is nothing but change of origin. What I am doing, I am changing the origin by adding and subtracting. So you always plus or subtract or add or subtract. Now what is change of scale? Understand? Change of scale means you are multiplying or dividing. Okay, suppose you find another variable, suppose y3, you doubled it. So when you double, you are multiplying. Okay, so means you are doing the change of scale. So 2, 4, 6, 8, and 10. And when you divide, that is also change of scale. So when you divide or multiply, it is change of scale. Suppose you divide each observation by 2. So you are getting 1 by 2, here 1, here 3 by 2, here 2, and here 5 by 2. So this is nothing but the change of scale, and this is change of origin. All of you understand? Please blow your thumbs. Okay, so there should not be any doubt on this. Okay, so this is the change of scale, and throughout the next unit, you have to remember it. Now, properties of covariance are covariance between the same variable is the variation itself, variance itself. Now, effect of change of origin. So, covariance is invariant to the change of origin, but it affects with the change of scale. Means, what do you mean by that? What is the effect of change of origin? So I do not write the entire sentence, but if you find the covariance between x plus, suppose I give you a situation so that you will quickly understand. Suppose covariance between xy is equals to 0.5. Okay. Okay. Suppose I define new variable. Suppose x plus 2 and y plus, or suppose I do one thing, I reduce here. I take both the example. Y is subtracted by 1. Suppose y minus 1. Okay. Suppose this is u and this is v. Okay. So then covariance will not be changed. If you find the covariance of this, it will, you will never experience any change there. It is not affected at all. Okay. So change of covariance is independent of change of origin. प्लस माइनस करने से ओरिजिनल वैल्यू चेंज करने से कुछ भी नहीं होता. सपोज ये वाला. Okay, so this is, but when you do the change of scale, means let I define another variable. Suppose it is I multiply it twice, we doubled it, and v is, suppose I subtracted, or any other variable. Suppose I take y divided by 2, suppose. So definitely there will be difference. There will be difference. Yes, there will be difference. It will not be the previous one which it was. Okay. So it means that uh, covariance is affected with the change of scale. Okay. So when you do the calculation and get the value, you will see it is not 0.5, which is the original value, right? So that's why you say that the covariance is not independent of change of origin, not independent of change of scale. Okay, so this is the case. Okay, so I hope you understand. because I can't take in detail, but definitely I can give you idea how it works. Okay, if you understand, please blow your thumbs. Well, so now let's come to the point. Yes, thank you very much. Carl Pearson. Carl Pearson correlation coefficient. This is important to us. Okay, correlation between x y. So what is the formula? Covariance between x y upon sigma x sigma y. So this is the formula. This is the formula between covariance. Okay. Now each term, there are three terms involved in this. There are three terms involved in this, and both have their unique formulas. If you change the formula, you will get a different formula. Okay. So this is the very basic formula. Now covariance, you know what is the formula? Summation x minus x bar into y minus y bar upon n, or it can be written summation xy upon n minus x bar into y bar, right? Now sigma x means the standard deviation of x. Now you can write like this, summation x minus x bar whole square upon n, or okay, you can also write like this, summation xi square upon n minus x bar square. Okay, and sigma y, this is nothing but the standard deviation of y. That is y minus y bar whole square upon n. Or in the simple way, you can write this summation x I sorry, it is y I square upon n minus y bar square. Okay, so this is y bar square. So these are the way. So accordingly, there are different forms. You have to understand it. Okay. So what are the different forms of this? So derivation is not possible here. We will not take the derivations here, but definitely I can mention the various forms here. Okay. So if you could remember, then you can. Otherwise, this is the very basic formula. You can easily remember this, and you have to remember the terms in it. Okay. So what are the various forms there? Suppose you put the values of this. What you will get? You will get another form, x minus x bar into y minus y bar upon what you will get. If you solve this, you will get another form like this. Square root of summation x minus x bar y minus y bar whole square. So this is one other form. This is first formula. This is another formula. If you go on solving as per this simplified formula as the second term in this all the three, so you will get another term. Okay. So for example, you will get term like summation xy minus n times x bar y bar upon square root of, and this one you will get summation x square minus n times x bar square into summation y square minus n times y bar square. So this is another formula. But when you put x bar and y bar like summation xi upon n and summation yi upon n, so you'll get one more formula. This is one of my favorite formula. So all the totals are there. So this is summation x into summation total of x into total of y, and here it is n summation x square minus summation x ka whole square. Okay, and here n summation y square minus summation y whole square. So this is one of the favorite formula. When you have all the totals, okay, then you can use this formula without going to this. Okay, so summation xy, you know, summation x summation y, know, and summation x square y square, you know, then you can directly put this formula. Okay, so when I know when you have all the totals, then you can directly go to this. Okay, so these are the various forms. Again, the formula will change if there is a change of origin and scale is used. Okay, so change of change of origin and scale. In that case, you have to x you will change with u and y you will change with v. Okay, and u and v will be defined whether it is change of origin or change of scale accordingly. Okay, so there may be more formulas in this list if change of origin and scale is used. In that case, you have to remember the property of change of scale, and you have to replace x with u and y with v. All of you understand? Okay, thank you. So now this was the calculation coefficient, correlation coefficient. Now let's come to the properties of correlation coefficient. So very important question. You should remember the properties. Okay. So what are the very first property? The very first property is it is it lie between 0 and 1. Okay. What is the first property? It lie between 0 and 1. So that is the very basic property. Very first property, correlation lies between -1 to +1. Okay, -1 to +1. Secondly, the now this thing you need to be noted. This is very important point. Now correlation coefficient does not change in magnitude. The change of origin scale. Okay. Now I'm writing a statement. You try to understand it. Otherwise, I will explain it with the help of example. So H, suppose correlation between H, x minus a upon H and y minus b upon k. So this will be correlation between xy. Now what is the condition? H and k same sign. Same sign means both positive, both negative. Okay, both positive or both negative. I want to say that one. And it will be minus correlation xy if H and K have opposite sign. Now, many times a tricky question asked on it. So you have to note it down properly. Okay. So, sir, I didn't understand. So that can be your case. Okay. So don't worry. I take simple example. See, what is H and K? Now A and B, what is this? Change of origin. And it is absolutely not bothered with it. But what is H and K? These are the constants for change of scale. Okay. Now we have to focus on H and K. Okay. I take one example. Instead of theoretically speaking, I practically solve an example. Now, suppose I want to find correlation between x minus 2 upon 5. Okay. And here y minus 1 upon 4. So what will be my H and K? H is 5, K is 4. So both are positive. Suppose I know that their correlation is 0.6, right? Okay. Just a minute. There is some mistake. Okay. I know that what information I have, correlation between XY is 0.6. Okay. And now I have to find out this. Now, first of all, I identify what is the constants for change of scale. Okay, so 5 multiply or divide. Okay, so multiply side, these are the variables, these are the constant, right? This is divided. Okay, when you say change of scale, when multiply or divide, now these are divided by 5 and divided by 4. So these are the constants for change of scale. Okay, so both have positive sign. So I can quickly write here, it is nothing but 0.6. Okay, same as correlation between xy. Okay, understand this point. Now I take another example. I just do some arrangements here. X minus 2 upon 5. And here I write 1 minus y upon 4. It looks that it is positive, but it is not positive. So just I check it. I write in a proper way. So x minus 2 upon 5, and here I can write minus y minus 1, right? Can I write like this? Because here, see, my variable is minus, right? It is minus. So minus 1 minus, sorry, again the same mistake. I am writing here, I'm highlighting it. It is y minus 1. So minus y and minus minus plus. So I will get 1 minus y again, right? So this is, so upon 4. So if I rearrange it, so what I'll get, I will notice that the signs are not same. So ultimately I will write the sign here, minus 4. Okay. So it is carrying minus sign there, numerator here. So it is minus 4. So what I noticed then, it is a simple change I am doing. I noticed that the quantity by which I am dividing means constants, change of scale constants, 5 and minus 4, opposite sign. These are having opposite sign, right? So therefore I should put directly minus sign here, and I will mention that it is minus correlation between xy. That's it. You have to do nothing. It will be just the magnitude. uh, the value will be minus 0.6, nothing else. Okay, it will not change. Correlation magnitude will not change. It will be zero point 0.6 only. But when to put x, when to put it positive value, if both are negative or both are positive. Understand my point? Okay. Now here both are positive. Suppose it was minus 5 and minus 4. That time also it works. Okay. That time also I will put plus sign. What I said, same sign. Same sign means both either positive, both either negative. Now here, what's happening? 5 is having plus sign and it is minus sign. But suppose we reverse it and 5 is minus or this is plus, but they are having the opposite sign, right? So in that case, I will put minus sign there. Okay, directly minus sign you have to put. And if you do not remember the property, you say that by the property of correlation. That's it. Okay, so how many of you understood? This is very important, and you can be asked a short question on this. Okay, nobody understood this? Okay. Suraj Patil have a question. I will take one more example, right? Okay. I will have one more example so that you can understand. I understand your way. I understand your concern. You need more examples, right? If I'm true, please blow your thumbs. So I'll take more example. Example number second. Suppose correlation between x and y is 0.4. Okay. And now I want to find the correlation between x minus 2, y minus 1. So it will be definitely correlation between xy. It is 0. 0.4. See, observe that either you multiply it. What is the division? 1 and 1. If nothing is there, their denominator is 1, right? Or nothing is multiplied. Suppose 2, 3. Okay. Now it is, you can also write this. You can multiply with the same number. And you can also write this 3 upon 1, right? Isn't it? Do you understand? When you write a single number, you can also write like 3 into 1. Or you can also write it 3 upon 1. You will get the same result, right? So you can multiply or divide with the same constant, right? So in this case, it comes 1. You can also take multiplication as I did here. Okay. So what I observed that both are having the same sign, positive sign. Or you can also take minus. Suppose you want to write in 2 minus x upon minus 1, or 1 minus y upon minus 1. So in that case, both will be negative. So in both the cases, they are having the same sign. Both are positive or both are negative. When both same sign, you write the same thing. Means Understand? No. Now another example, one more example I take. By default, any not understood. Suppose now same, I'm taking the correlation value same, and suppose let u is equals to x by 2 and v is equals to 1 minus y by 3. Okay. So first of all, I will make a change here. It will be minus y minus 1 by minus 3, right? I have to mention the variable first. Okay. So I did like this. So 1 minus y is it? 1 minus y upon 3 means it is minus y minus 1 upon 3. I did a final step here. Minus 3 यहाँ पे लिख दिया. तो यहाँ पे क्या हो रहा है? Here and here. Opposite side. Okay. So here the correlation value will be minus 0.4. I take some more example. Suppose u is equals to twice x minus 1 and v is equals to 3y plus 1. So now what I observe here, these factors, constants, same sign, right? Both positive. So what I will write? Yes, their correlation is 0.4. Now one more example. Suppose u is equals to suppose u is equals to minus 2x plus 1. Okay. And v is equals to what? Minus 3y plus 1. Okay. Let's see. So now again, I observe that this is minus 1 and minus. I'm not thinking about this. What comes after plus or minus, I'm not thinking. I'm not bothered about it. Okay. Because it is invariant or independent of change of origin. I'm thinking about the multiplied sign or a multiplied constant or divided constant. Okay. So this one. So both are minus there, right? So again, I will mention here 0.4 only. Okay. So I hope you got. We have spent much time on this. So hope nobody have doubt. Okay. So quickly give your thumbs. If you understand, we'll go further. Thank you. So now we are in the end. Entire topic we cannot explain, but yes, basic things we can definitely explain. So now state the types of correlation for the following. Now sale of woolen garments and day temperature. Woolen garments. What do you think? Woolen garments and day temperature. So if the temperature, now let's take it temperature and woolen garment. Now as the temperature increases, टेम्परेचर जैसे बढ़ेगा हम वूलन के कपड़े नहीं खरीदेंगे, है ना? Okay, those needed in the winter. As the temperature drops, as the winter temperature goes below, okay, then in that case the woolen clothes are demand. So what you see, opposite kind of change you can see here. So here there is a negative correlation. Negative correlation. Such kind of question can be asked. Now supply and price of onion. Okay, if the farmers have grown the onion in abundant way, बहुत ज्यादा यानी कि अच्छी फसल हो गई है, तो ज्यादा माल है, तो ज्यादा क्वांटिटी है, तो उसके डिमांड प्राइस जो है वो कम हो जाता है, बिकॉज दे हैव टू अल्टीमेटली सेल इट. ओके, सो व्हाट्स हैपनिंग हियर, supply increases, then price of onion decreases. Now you can see that in the market there are lots of onion are there. Okay, so the value of price of onion is around 10 to 15 kg rupees kg per kg rupees per kg, right? But when the stock is not there, so in that case you say that supply is reducing, means there is no stock, then in that case it goes on upside, prices increases. स्टॉक ही कम है, 50 किलो चाहिए पर वहां पे 10 किलो ही है, तो उस वक्त वो 10 किलो की प्राइस बढ़ जाएगी. ओके, सो दे विल सेल इट इन द हायर प्राइस. ओके, सो नेगेटिव कोरिलेशन. द स्पीड ऑफ व्हीकल एंड डिस्टेंस कवर्ड टू स्टॉप द व्हीकल आफ्टर अप्लाइंग द ब्रेक. तो इसमें जो है स्पीड जितना ज्यादा रहेगी, जैसे कि ये बाइक है, ओके, दिस इज अ बाइक, दिस इज बाइक। आपने ब्रेक अप्लाई कर दिया, तो जितना ज्यादा स्पीड रहेगा, स्पीड जितना ज्यादा रहेगा, डिस्टेंस इतना ज्यादा आगे जाएगा ना। ब्रेक अप्लाई करने के बाद डिस्टेंस ज्यादा होगा। ओके, सो इफ स्पीड इज मोर, डिस्टेंस आफ्टर अप्लाइंग द ब्रेक विल बी मोर। इफ स्पीड इज लेस, अगर कोई 50, अगर कोई 120 की स्पीड से गाड़ी चला रहा है और ब्रेक मार दिया अचानक से, तो वो 15-20 फीट जो है वो आगे घिसटते हुए जाएगी, राइट। वही अगर 30 के स्पीड से कोई गाड़ी चला रहा है और अब भी अगर आपने ब्रेक लगाया, तो वो थोड़ा ही दूर उसका जाएगा। सो दैट इज द सिंपल लॉजिक देयर। सो what kind of correlation will be there? Positive correlation. Income and expenditure, again positive correlation. First two were negative. Amount of yield of grain and length of leaves. Okay, amount of yield of grain, length of leaf. Do you see any relation between this? I don't see any relation, so there is no correlation or zero correlation. Height and blood pressure of a person. Uh, I think there is no correlation, but yeah, height and weight are related, and weight and BP are related, right? So indirectly it can affect it. Okay, so there is not a direct relation, but yes, there is an indirect relation between them. In the case of doubt, you can say it positive correlation. Okay, all of you understand? So now we are coming to the end of this unit. Now again, there are some questions. Interpret the following values. So what you will say, just tell me. I'm trying to cover the different types. I believe that you can do the numericals by using the formulas I had given. Okay, so there should not be any worry. You have to follow the steps and you can solve it. I believe that. Now you have to interpret the values of Karl Pearson correlation coefficient. So if R is equals to 0, what do you mean by that? Yes, no correlation. There is no correlation. Okay, so R is equals to 0.6. How will you interpret? You will interpret as positive correlation. What is positive correlation? R lie between 0 and 1, right? Then R is equals to -1. Perfect. Perfect negative correlation. Perfect negative correlation. R is equals to +1. Perfect positive correlation. Okay. If R is equals to -8, again negative correlation, and R is equals to 2, again this is positive correlation. Okay, so you have to write that one only, nothing else. Okay, so did you all understand this? Okay, so now in this lecture it is not possible to solve the numericals, but yes, I will definitely give you the hints. Okay, so when such kinds of direct questions are there, then remember, first step will be, okay, first step will be you define the variables, right? Okay, so let x is what, y is what. Okay, then step number 2, you get all the totals you will need. For that you must know the formula. So I will suggest you to, there are many ways. We have seen that there are many formulas, right? But I will suggest you that you can use here this one. It will give you the direct formula, right? Summation y upon n summation x square minus summation x whole square and n summation y square minus summation y whole square. Okay. Now look at this. You will get a guidance from this formula that you have to prepare a table. So prepare the table x, y, x square, y square, and x into y. You have many ways to solve this. This is not the only way. Remember, okay? You can also use the formula covariance between x y upon sigma x into sigma y, mean both standard deviation. Okay, then you start finding x bar, y bar. I'm telling you alternate way. Then sigma x, sigma y, then covariance x y, and then you find the correlation using the formula above. Okay, so but this is my personal way. I'm not recommending. If you like it, you use it. So then get all the totals: summation x, summation y, summation x square, summation y square, summation xy, and see the value of n. N is the number of pairs of observation. In this case, how many pairs are there? 1, 2, 3, 4, and 5. So n is equals to 5. Okay. So once you get all the totals, then put it in the value, put it in the formula, and final step should be interpretation. Don't forget interpretation. If you don't interpret the values, either positive or negative, will cut the marks. Okay, because when you are finding the value, when you are getting the value of correlation, then you must be able to interpret it. So you must write a statement that there is a positive correlation, or there is a negative correlation, or there is a no correlation. So remember these 5 steps. Okay, so when you are given the raw data like this, you can use this. Okay, so this is the now quickly in within 2 minutes I will explain you the I will tell you about the rank correlation, or better I will cover it in a separate session. Okay, so now so thank you very much. Up to this part you must have understood. So now I will take then another session for next portion. Okay.
Sir,